I'm just kidding, I can talk. Hello. I rarely do YouTube tutorials. It's been so many years, so it's so fun to do it again. All right, let's cut to the chase. So, you want to do multiple beams in one Niagara system. Um, well, this is going to take you up to this point because you basically have to remake a lot of it from scratch, and I only needed to do this up to a certain point for my own effect in my own game, and but I wanted to show you guys how to get to this point too, because I've tried searching it up on the internet myself, and not there's not really any answers to how to do it, so that's fun. Um, there's some answers to how to make multiple ribbons, but not really multiple beams using ribbons. So yeah, I'm going to show you how to do this with a CPU Niagara emitter and a GPU Niagara emitter. So let's get started. All right. So step one, we're gonna make a new Niagara system from scratch. So we're gonna hide that. New Niagara system. We're gonna start with the dynamic beam. NS beam new. Perfect. All right. So we got our beam. We're gonna hide the background. And we're gonna just do some quick updates to it. All this new version stuff. Fix issue, dismiss. Fix issue, dismiss. Fix issue, dismiss. And then it resets the beam length when you do that. So we're just gonna make this in beam emitter setup, beam end to 255. Well, actually, yeah. So if I go rotate, it's a little bit long that way. And we're gonna make it slightly longer lasting, like 8 maybe. All right, so we're gonna start with the CPU one first. Um, and so the first step is to make a way to like spawn these beams. And so with that, I start with add emitter, right click add emitter. I do hanging particles just to get like a really basic like these particles spawn sort of thing in a field. And then we're just gonna delete a bunch of stuff we don't need. Aerodynamic drag, wind force, scale right size, scale color. And now we just have spawning particles. Um, and right now that's a ton, so we'll just do 5 on the spawn rate. And we'll make them bigger, so initialize particle, go to sprite size, uniform, make it like 25 or 20, big. All right, cool. So in the CPU version, we're basically going to use death events and stage stuff. Um, and the first step we'll do is go to properties on the hanging particles, turn on require persistent IDs. And next thing is to go to particle update, type death, generate death event. Cool. And let me make sure that there's nothing fancy. Yeah, that's fine. All right, cool. Now we got our spawning particles. And now we are going to add a event to the dynamic beam. So go to stage, event handler. There you go. And then go to our source, click that def event. Very important, change the execution mode to spawned particles. Um, and for now, we are going to disable spawn burst instantaneous because we're going to be spawning them from the event handler. So turn that off. We're going to make this like, let's see what I put, 44. Yeah, for the spawn number on the def event. Next, we're going to add the receive def event. So I usually just type def again, receive def event. And for the position, we're going to change this from apply to output because we're going to manually apply the position ourselves because this doesn't really work for us. And for the ribbon ID, kind of the same. We're going to change that to output because we're going to use that later. All right, so nothing much is different. Um, Also, for now, we are going to disable update beam because we will fix that later. All right, we got our beam just sometimes there, I guess, whatever. Um, let's see, in emitter self, we're going to change this loop duration from 4 to 1. Okay, so I was just like, why isn't the beam spawning? It's because our lifetime of our uh, initial parent particles is pretty long, so we're gonna make that way lower. So because the beam only spawns once the particle dies. So we'll go to initialize particle, change that from random to direct set, and there we go. So now we have the beam basically spawning over itself, but it's not acquiring the position of the parent particles. And we're going to do that right now. So in the event handler, we are going to add a scratchpad module, and we will call this module beam offset. If you don't know what any of this is with modules, I highly recommend watching a tutorial on just modules because they are very, very nice and important. Um, so we're going to put this module editor side by side with our system overview. And now we are going to offset our particles. So first things first, we're going to get all the attributes that we need. Um, with this receive def event, we get some pretty important stuff. We get the position of the particles from the parent particles, and we get the ID of those particles that we can feed into our offset. Um, so we'll go to parameters, and I'll just start listing them. We're going to scroll down to module outputs. There's that vector 1 from that receive def event, which is the position. We'll put that in our map get. Click over here. By the way, if you click between these two, you can see this active module, active overview, so you know which one you're in. Um, so also from that module stuff, we'll get the Niagara ID. Cool. And then from here, we will add we'll hit the plus here, get the position and the simulated position. And so this is just the current position of the particles. This is for like if you're moving the particle system around in your scene, stuff like that. So for the map set, we are going to hit plus, type position, and hit plus, type ribbon ID. Cool. All right, so let's offset our beams so that they're not overlaying over each other. So we're going to add the received event vector 1, which is the position of the parent particles. We're going to add that to our position. So first we're going to position to vector. I don't actually know if you really need this, but I see everybody else using it. All right, so you add that to each other. And then we're going to subtract that from our simulation position so that our beams appear in the right place with our Niagara system if we move it in our scene. And we'll change this from vector to position. And then that goes into your position. Hit apply, and you'll notice, you'll be like, oh my God, what is that? Well, if you turn off ribbon render, that is sprite render, you'll see it's actually doing the right thing. But because our ribbons don't have the correct IDs yet, they're freaking out and they think they're all the same. So, and as you can imagine, just drag from your Niagara ID into your ribbon ID. Wow, beautiful. Look at that. Um, the last thing I'll show you where I sort of stopped on the setup is how to like get them to kind of move and like basically hijack this update beam node. Because after you turn this update beam node back on, um, they spawn where they're supposed to, but then they move back to their original coordinates. And this update beam is literally just for if you have a beam emitter setup, if you're animating these values, um, this update beam is what allows them to animate, which is why it's like, ah, what's going on? Um, so I'm just going to show you how to update or animate the length, because that's where I sort of stopped. So for that, we're going to make our own update beam. So we're going to make a new scratchpad in particle update. New scratchpad module, and we're going to name this beam. I called this beam update jank. So there you go. Like this is not perfect. Don't get me wrong. This is just to help you get kickstarted on something better. So I bet there's a billion ways to do this better. Don't get me wrong. Okay. So from here, we are literally just gonna double click our update beam node, the original one, which opens that asset. We're gonna copy all this stuff, copy just the guts here, go back to our Niagara system, and then we're just going to paste that in our beam update jank, and then we're just going to rehook it up. So delete our original map get, map set. We're going to plug this input into our map get here. Map set, we're going to plug that into that input there. And then this output thingy, we're just going to put that there. Hit apply. And now you see our module does the same thing as the update beam. Now the only difference so that it stops doing that is we are going to add a position to the map get. Particles position, and then position to vector. And instead of this beam start, we're going to plug in this vector. Hit apply. Yay, so now they're in the same correct alignment. And then in order to change this so that they're not shooting out like crazy, you go to your beam emitter setup, change that from 255 to like way shorter, like 5 or something. And then there you go. Yeah. So I'm going to hit save. I'm going to drag that into our scene. There you go. Multiple beams to do stuff with. Now, is it perfect? Is it this kind of janky? Absolutely. Um, but hopefully in the comments we can take it further because nobody's talking about this. All right. So now I'm going to show you how to do this, but with the GPU. And you might be wondering, like, why a GPU? For my own effect, I wanted to do something where it's like move to nearest distance field GPU, which basically makes the particles like move along the surface of objects, but it's only GPU. So I had to figure out how to do this for that. So to start with that, let's see, I'm just going to save real quick. I'm going to close this modules for now. We're going to copy our hanging particles right there. And then we are going to delete this generate depth events because that doesn't work for GPU. So we're going to click properties, change that to GPU. We're also going to turn off the visibility of our old stuff. Now we have GPU parent particles. Cool. Give me 1 second. Okay. So from here, let's just make sure this is all fine. Emitter state. We're gonna make this once and set it to infinite. And that's sort of kind of it for the parent particles. Um, and then for the beam, we're just gonna make a new beam from scratch. So dynamic beam. There's our cool beam. Um, we're gonna go to properties, make that GPU, and it's gonna complain and be like blah blah blah. We're just gonna ignore it, and then we're gonna fix the issues with our beam stuff. Fix issue, dismiss. Fix issue, dismiss. Remember to go to beam emitter setup. Make that something normal for the beam end. All right. So now everything's GPU. Also, if one of these is CPU and the other is GPU, none of this will work. They either both have to be CPU or both have to be GPU. All right. So where to start? So instead of event stages, we are going to use sample particles from other emitter, and we'll do that in emitter update. So sample, uh, sorry, spawn particles from emitter, from other emitter. There we go. And it's going to be like fix issue, okay. And then it's going to spawn this sample particles from other emitter. That's what I was thinking about. Um, and we're going to hit fix issue because this needs to be below the initialized particle. Cool. So basically, sample particles from other emitter, we're going to act like that's our receive def event where we get all these cool attributes. So instead of applying position sampling, we're just going to output it. And then for particle ID, we're going to output that. Turn off this reject particle if sampled index, blah, blah, blah. That just fucks with it. So from here, let's start with emitter state. So infinite, yep, this is fine. We're going to make this loop duration 1. You should definitely do this to start because it sort of freaks out if you don't. Let's see, spawn burst instantaneous. We're going to make that 15. For spawn particles from other emitter, we're going to hook this up now. So in emitter binding, we're going to look for hanging particulates 001. And the funny thing is, we're going to make the spawn rate 0 because we are basically just hijacking this node for its particle attribute reader. So we don't need none of that. And now you see we're back to the stage where the beam spawns on itself over and over, which is great. So now we're just going to remake the beam offset, but for the GPU. So, and you'd think like, oh, I could just copy the one I made here. No, because those are different attributes and it would freak out. So we'll just make it from scratch again. Particle spawn, new scratchpad module, put down the side here. All right, let's see. All right, so let's get our attributes back in. We're going to type in here position, simulated position, and now we're going to get the particle, we're going to get the stuff from, oh, actually, this is jank. Let me name this properly. Scratch module. We're going to call this beam offset GPU. Cool. Now we're going to click into our system overview, go to parameters, and on the output stuff, so module outputs, we are going to bring in sampled position and sampled ID. Cool. And then for our outputs, we're gonna do position and ribbon ID again. Position, ribbon ID. Cool. And so it's basically the same stuff as the last module we made. So we're going to take our position, do position to vector, and we're going to add that to our sampled position. And then we're going to subtract that by our simulated position and do vector to position. Oh, position. And feed that into position. Hit apply. And it doesn't work. And the reason why is because we have update beam still on. So turn that off because we have to fix that. And now we're back to where we were before with the swirlies, which is cool. And as you can guess it, sampled ID goes into ribbon ID. Hit apply. Woo! Look at that. Look at that. All right. So for the update beam, I'm pretty sure we can just reuse the one we made, our jank one. And so I'm going to put that particle update into here, copy paste. There you go. Oh man. All right, so beam emitter setup, make that from 255 to like 4, 5, whatever. There you go. GPU beams. Very cool. Let's see. There they are. And now with those, you can use move to nearest distance field GPU, offset this by like, I don't know, 15. Look at that. Ain't that cool? Probably so much work any other way. And that's it. Oh, that's kind of rad actually. All right. So yeah, it's not perfect, but if anybody has some suggestions in the comments, totally down to take those suggestions. I'm still like, I don't need to recreate the beam setup from scratch. That's why I'm like, I'll just post what I have here. Um, but yeah, if anybody has suggestions, let me know. And thanks for watching.